A small object of mass 10 kilograms is suspended by two light, inextensible strings from a fixed rigid beam as shown in the diagram. We want to find the tension in each string. So let's call the tension in this string T1 and the tension in this string T2. What we want to do is resolve these forces horizontally and vertically. So let's start with T1. This is horizontal and therefore parallel to the beam. So we have alternate angles here, meaning that this angle is 45 degrees. So the component in this direction is T1 cos 45 degrees, and in this direction, T1 sine 45 degrees. Let's do the same thing with T2. This angle would be 60 degrees. Again, because we have alternate angles. So the component in this direction is T2 cos 60 degrees, and vertically we have T2 sine 60 degrees. And of course, we have the weight downwards. If the mass is 10 kilograms, then 10g is the force acting downwards. And in all of these examples, I'm taking g as equal to 9.8. Since the object is in equilibrium, we must have that T1 cos 45 is equal to T2 cos 60. In other words, the horizontal components must be equal. Let's call that equation 1. And then looking at the vertical components, T1 sine 45 add T2 sine 60 must be equal to 10g. Let's call that equation 2. Rearranging equation 1 gives me that T1 is equal to T2 cos 60 divided by cos 45. And then I can substitute that in here for T1. So we'll sub into 2, and we have T2 cos 60 over cos 45 times sine 45 plus T2 sine 60 is equal to 10g. Factor out the T2 would be the next step. But before doing that, what I've done is I've just brought the sine 45 onto the top of the fraction, because remember we're multiplying by that. So cos 60 sine 45 over cos 45 makes it clearer what this term actually is. So I did that as a prelude to factoring out the T2, open a bracket, and then we've got the cos 60 sine 45 over cos 45 add sine 60 equals 10g. And so T2 is going to be 10g divided by the whole of this bracket. So all we need to do now is calculate, and remember I did say that I used g as 9.8. So T2 is 71.74 newtons, correct to 2 decimal places. And then we know that T1 was T2 times cos 60 divided by cos 45. That was the rearrangement of equation 1 above. And calculate that. I think I used the whole value on my calculator display rather than just 71.74 in calculating T1 to be 50.73 newtons, correct to 2 decimal places.